In this video, we're going to look at how to calculate the percentage of sales against the total sales. Our data set has a list of products and the sales for each product. We would like to calculate the percentage of each product sales against all product sales. Perhaps the most common way of doing this is to write a simple formula within the table of the data. So selecting the first product, we'll write a formula such as equals, and we'll take the first product sales, B2, and divide it by the sum of all of the product sales, B2 through B11. Of course, we need to fix B2 through B11, hitting the F4 key, so that when this is repeated, we don't lose that reference. Now, these all look very ugly in terms of percentages, so we'll select this column, and we'll give it a percent style, and we'll give it 2 decimal place precision. And now we know the percentage of sales for each product against all products. Another way to create this report would be to use a pivot table. So I'll select the data, and I'll go up to Insert, Pivot Table. Now, I don't want to include the original percent of sales answers in this pivot table, so I'm going to narrow the selection to just the original products and sales. And I'll put the output of the pivot table here on this existing worksheet. We'll add the product to the rows and the sales to the values. We'll do a little cleanup here. I'm going to go up to Design. I'm going to switch this to a tabular layout. That way I can get my nice heading back. And I'm going to rename this title to Sales. And I like to align these things with the values. We'll also stylize the values a little bit. Right-click Number Format, and I'll give it a currency style with no decimal places. This now more closely resembles the original table. The trick is to add sales a second time to the values. This duplicate set, currently being the same results as the first set, a sum, I'm going to right-click and choose Show Values as Percentage of Grand Total. We can now take this list and right-click, Sort Largest to Smallest, and get the same report as the previous. I'll customize the title, percent of sales, and I'll left align it. Another way to create this report would be to use Power Query. I'll select the original data set and then go up to Data, and in the Get and Transform Data section, From Table Range. This will bring the data into Power Query. So we can keep track of these steps more easily, I'm going to rename the Change Type step to Subtotals. We now need to create the denominator that will be used to divide each of the sales. We'll select the Sales field, then go to Transform, Statistics, and Sum. This uses the sum function from the list library to get the total sales from the subtotals step. We need to return back to the original list of subtotals. To do that, we'll click the FX button. That will by default refer to the previous step's results, which was called Calculated Sum, but we will change that and revert that back to the subtotal step. Now we're back to the original data. We want to now take each sales as the numerator and divide it by the calculated sum, which is the denominator. I'm going to rename the calculated sum step to total sales. I'll rename this step to Return to Data. Selecting the sales column, we'll click Add Column, Standard, Divide. Now, unfortunately, we can't refer to the step total sales, because this field is expecting some sort of value. So temporarily, we'll divide everything by 1. You can see in the M code we're iterating through each product and dividing the sales by 1. We'll take 1, which is the denominator, and replace that with total sales, which is a reference to a query step. We can now set the data type to percentage, and we'll rename the column Percentage of Sales. Now we're ready to send this report back to the Excel file. So we'll go to Home, I'll choose Close and Load 2, and this will give me the option to choose a location other than a new table. So I'll say let's go to an existing worksheet and put that right here next to the pivot table. Now Power Query has no responsibility for making numbers pretty, that's Excel's job, so we'll take a second and take the sales column and give that a currency style with 0 decimal place precision, and the percentage of sales and give that a percent style with 2 decimal place precision. We can also go to the table and turn on a total row, and we'll add a sum function at the bottom of the sales column. As you can see, each column has the same data. We just arrived at the solution 3 different ways. As a bonus, I'd like to show you how we can perform the Power Query method with fewer steps. Selecting the Power Query output, I'll go up to Data, Queries and Connections. Here's my query, and I'm going to right-click and edit the query. Looking at the Insert a Division step, this is where we performed the division for each row in the table. The sales column is the numerator, and total sales is the denominator. Now, total sales refers to another step in the query. If we look back at that step, that is where we use the list.sum function to get the total of all sales. Instead of calculating this number and storing it in memory, and then using it at every iteration of this division function, what if we were to take the actual list.sum function, and I'm going to copy this, return to the inserted division function, and put that in place of the total sales reference. This way we're actually determining the total at each iteration. The results of the inserted division step have not changed, but now we can return to the total sales step and remove that step as it is no longer needed. Looking at the inserted division step, everything is still working properly. This also means we no longer require the return to data step, as we are not leaving the original data source. So if we look back at the steps now, we're connecting to the source, we promoted the header row, we have our subtotals, this is essentially where we set the data types, then we just perform the division directly. The next step was to set the data type to a percentage data type, as the original data type assignment was set to a decimal number. We can see in the M code, type number, this is what gives us the decimal data type. Instead of having a whole nother set just to set the data type, what if we were to take the data type, percentage.type, and copy that, return to the original inserted division step, and replace the incorrect assignment with the correct assignment. This way we can start right out of the gate with the correct data type. Using the same philosophy, when we renamed the column, we were renaming from division to percentage of sales. Let's take percentage of sales and copy that and return to the original inserted division step, and this is where we started with the incorrect name and just give it the correct name. And now we just begin with the correct name instead of having to change it in a later step. So now we no longer need the change type step because we set the data type when we created the formula, and we no longer need the rename column step because we started with the correct name. So now we have reduced the number of steps in this query down to just 4. Now in full disclosure, there is some merit to having calculated the total sales as a separate step. If we're calculating the total sales at each iteration of the table, in this case, we have to perform that calculation 10 times because the denominator has to be determined at each record level. With a small table, this is not really an issue. If you had a table of millions of records, this could impose a large cost on processor time. So creating the denominator as a separate step and referring to it is much faster than having to calculate it at each iteration of the table. Let's go ahead and send this data back to Excel. And now you see the 3 different ways of creating the percentage of sales for each product against the entire product base. Thanks for watching, and remember, at BCTI, the learning never stops.